All right, today we are going to be talking about simplifying radicals. Right now, I think we talked about this the other day, but another name for a radical is just a square root. Okay, so pretty much we are simplifying square roots today. Okay, and what do we mean by simplifying square roots? Okay, well, I know some of you have seen this type of square root before. And so today we're going to kind of go from the square root of 125 to 5 times the square root of 5. Okay, so 5 times the square root of 5 is the simplified version of it, and we're going to talk about how we get there. Okay, so I know some of you maybe already know, so hopefully this won't be too bad of a lesson for you. All right, so we always start with a square root that is not a perfect square. Because obviously if we had the square root of 25, we know that's just 5. That's simplified. Or the square root of 100, we know is just 10. That's simplified. Well, the square root of 50, if you type that into your calculator, it's a random decimal. Okay, and we want to simplify this the best we can. Okay, it's kind of like simplifying a fraction. Okay, like if we have 4/8. Obviously 4/8 is like fine, but we know that that's better if we simplify it down to 1/2. So that's what we're going to be doing today. I'm going to start with the square root of 50 because 50 is a nice number to work with, an easy number to work with to start, and then we'll get into some more challenging ones. When we are simplifying square roots, we always want to find all of the numbers that can be multiplied to give us 50. So for example, 5 times 10, 1 times 50, 2 times 25, and don't think there are any others. I think those are the only 3. And then I look at my list of numbers here and I notice, okay, are there any perfect square numbers up on the board? Hopefully some of you notice that, oh, 25 is a perfect square because I literally just talked about it in the last slide. Okay, so square root of 25 would be 5. That's what makes 25 a perfect square. Okay, our perfect square numbers are, for example, 4, 9, 16, 25, 36, 49, 64, and so on. Okay, those would be our perfect square numbers that we're looking for. Okay, so here we found one, 2 and 25. Okay, so all I'm going to do is rewrite the square root of 50, but I'm going to rewrite it as 2 times 25. Means the same thing. Okay, I'm going to separate it out. Square root of 2, square root of 25. Okay, so all 3 of these mean the exact same thing. Right? Then we picked a perfect square number so that we could get a whole number out of it. Square root of 25, well, that's just 5. Okay, so my final answer is going to be 5 square root of 2. Okay, so my first step, let's kind of go backwards here, is I took 50 and I found all of the possibilities that multiply to give me 50. I then went through those and I noticed 25 was a perfect square, so I used 2 times 25. Okay, so I put 2 times 25 in instead. I separated them out. Sometimes people like to do these first 2 steps like as one. That's fine, no big deal. Right? And then I simplified the perfect square number and I got 5. And I always like to put the whole number out in front because sometimes if we put it behind, it looks like it could go under the square root depending on how long you make your square root. So they like to put that whole number out in front. All right, the next one here, let's do 18. So same thing, we're going to start by finding all of those numbers that can multiply to give us 18. 1 times 18, 3 times 6, 9 times 2. Am I missing any? Sometimes I do. I think I'm good. Okay, and I notice, all right, are there any perfect squares? Yes. 9 is a perfect square number, so I'm going to use 9 times 2. So I'm going to rewrite this as the square root of 9 times 2. I'm going to separate them out. Square root of 9, square root of 2. I'm going to solve that perfect square number. Okay, that perfect square number is equal to 3. So I'm going to rewrite it as 3 square root of 2. Okay, so this is the square root of 18. Right? If you have your calculator, you can actually take a second and type both of these into your calculator, the square root of 18, press enter, and then 3 times the square root of 2, and then press enter, and they should equal the same thing. If they ever don't equal the same thing, you didn't simplify correctly. All right, next one, we have the square root of 36. Right? And I always like to throw one like this in here because some people like to start off by trying to find all of the numbers that multiply to give us 36. Okay, but hopefully some of you are like, no, Mrs. Schmidt, you should stop right here because 36 is a perfect square because 6 times 6 is 36. So the simplified version of that one is just 6. So every time you have a perfect square number underneath the square root, just simplify it like normal. Easy peasy. All right, here we got the square root of 48. Okay, the square root of 48, there are multiple numbers, so let's see if we can get them all. Okay, sometimes I'm pretty bad at this. Well, I know 6 times 8. I know, what is it, 4 times 2, 48 times 1. I think 16 times 3 goes into it. Am I forgetting one? 4 times 12. What else? Do I have anything else? Or did I get them all? Okay, so 48 kind of has a few. I want to look for those perfect square numbers. And I notice, oh, look at 16 is a perfect square number. And I have 4 as a perfect square number. Right? I don't have any perfect squares in any of these other ones. So now it's like, okay, what do I do? Always pick the biggest perfect square. Okay, so 16. That's the one I'm going to use because 16 is bigger. So I'm going to rewrite this as 16 times 3. So I have the square root of 16 times the square root of 3. Square root of 16 is just 4. So 4 times the square root of 3. All right, let's do the square root of 27. Okay, hopefully a lot of you are looking at 27 and you're like, well, 9 goes into it. Okay, 9 times 3, 9 is going to be the biggest. Okay, 9 times 3, so we have square root of 9, square root of 3. Okay, but the square root of 9 simplifies to just 3. Notice that I got rid of the square root. And then we have 3 square root of 3 is the simplified version. We also have some situations where we're going to be multiplying radicals. Okay, so here we have the square root of 3 times the square root of 5. Okay, well, when I have the square root of 3 times the square root of 5, that is just going to be the square root of 15. We just multiply the numbers that are underneath and keep the square root over them. Right? And then I look at the square root of 15, okay, and can that be simplified? Okay, well, I got 5 times 3, 15 times 1, and I think that's it. Notice that there are no perfect squares. So that means the square root of 15 is the most simplified we can get. All right, when we have an example like this one, where we have whole numbers out in front of our radicals, right, you kind of treat it like combining like terms. You just multiply the 3 and the 5 together to get 15, and then multiply the square roots together. 6 times 2 is the square root of 12. Okay, now if we need to simplify this one further down, okay, well, let's do that. Square root of 12. Okay, what goes into 12? 6 times 2, 12 times 1, 4 times 3. Okay, and I look for perfect squares, and I notice, oh, there's 4, so I'm going to use 4 times 3. So watch this. We get 15, that stays like normal. We rewrite 12 as 4 times 3. Okay, just like the last problems. So nothing really changes here. Rewrite it. Square root of 4, square root of 3. Okay, and well, what is the square root of 4? That is just 2, so we have 15 times 2 times the square root of 3. Okay, so that means you can actually multiply 15 and 2 together. So we get 30 square root of 3 as our most simplified answer. So all of this simplifies to just 30 square root of 3. All right, let's do another one. Okay, again, 4 times 5, we just get 20. Square root of 3 times the square root of 6, we get the square root of 18. And we can simplify 18 down. Okay, 18, the perfect square, would be 9 and 2. Okay, so we can separate that out as the square root of 9, square root of 2. Okay, we know the square root of 9 because 9 is a perfect square. So we get 20 times 3 times the square root of 2. And don't forget to multiply 20 times 3 together. So we get 60 square root of 2 as our simplified answer. So again, all of this here is equivalent or equal to 60 square root of 2. I want to keep doing a couple more just to make sure that everybody's on the same page here. Okay, so we have 2 times 3 to get 6, 5 times 4 to get 20. And we can simplify 20 down because I know at least one perfect square goes into 20, and that's 4. Okay, so we have 6 square root of 4 times square root of 5, because 4 times 5 is 20. So we get 6 times 2 times the square root of 5. So we get 12 times the square root of 5. Okay, so all I'm doing is just some simplifying here. All right, here we go. We got 2 times, well, 2 doesn't get multiplied by anything. Technically, there'd be a 1 out in front here. So it's just 2. Then we have 8 times 3. So we get the square root of 24. 24 can be simplified down because we have the perfect square 4 times 6. 4 goes into it. So we get 2 times the square root of 4 times 6. 4 times the square root of 6. Okay, so we know the square root of 4 is just 2. So we get 4 square root of 6. Now, just like I said before, if you guys are ever unsure if you simplified correctly, plug this entire thing in and plug this entire thing in to your calculator separately, and you should get the exact same answer. All right, last but not least is what happens when we have a radical in the denominator. Whenever you have a radical in the denominator, multiply both the top, the numerator, and the denominator by the square root that's down below. Right, and we do this, right, so we get 3 square root of 6 on top, because 2 times 3, and we get the square root of 9 down below. Notice that when we multiply it by that number that's down below, we get a perfect square root in our denominator. So that means we can simplify this because we know what the square root of 9 is, so I can rewrite it as just 3. Hopefully, some of you are noticing that we can simplify this a little more because we have 3 over 3 here. Okay, well, they kind of cancel each other out here, so we're left with just the square root of 6. Okay, so anytime you have a radical in the denominator, you need to get it out of the denominator. Okay, square roots do not belong in the denominator. That is incorrect. Okay, they need to be brought up. Okay, and the way we do that is multiply by that radical that's down below. So let's do one more like this. Okay, we have the square root of 2 down below, so I'm going to multiply the top and the bottom by the square root of 2. So that means I have up top now 4 times the square root of 6, and down below I have the square root of 4 because 2 times 2 is 4. I'm going to rewrite it as 4 square root of 6 divided by 2. Last, I can simplify 4 divided by 2 to just 2. So my final answer is 2 square root of 6.